Now, light is a disturbance of the electric field and the magnetic field. So in fact, light is an example of an electromagnetic wave. So it's a transverse wave. So you've got here, this is one wave. This is the electric field, a wave traveling along it. Now I'll change color here. This is the magnetic field. And it's a wave which is perpendicular to the electric field. So these two waves, they're transverse waves. They travel from one spot to another, transfer energy. And light is actually an example of what we call an electromagnetic wave. But like all waves, electromagnetic waves can have different frequencies, and they can also have a different wavelength. They can also have different frequencies, and depending on the frequency and the wavelength of an electromagnetic wave, it will have really radically different properties. So these waves, different electromagnetic waves, fall into what we call the electromagnetic spectrum. So at one end of the electromagnetic spectrum, there are these extremely teeny tiny, so this is 10 to the minus 16 of a meter, so very small, just less than nanometers small waves, and they go 10 to the 24. The waves travel at 10 to the power of 24 times per second. So this is their frequency. So they're these really wavelengths which are really small, and they go really fast. They're really quite high energy. These are called gamma rays. This is in fact just here is a picture of all of the gamma rays of the Milky Way. So gamma rays are in fact flying around our universe the whole time. So there's lots of gamma rays here in the center of the Milky Way. They're hitting Earth right now, lots of gamma rays. And it's just kind of the way it is, not heaps and heaps and heaps. If you kind of sat in a gamma ray burst, it would be really bad for your health. They're really high energy. They can mutate your DNA. But there is this background radiation which exists around the entire universe kind of the whole time. As electromagnetic waves, their wavelength gets a bit bigger here. So we can see it goes on to X-rays. You may have heard of X-rays. They're great for looking at your bones to see if they're broken. As the waves, the wavelengths gets bigger and bigger again, you end up with UV waves. You may have heard of them. Again, they come from the sun and they burn your skin. So these gamma rays, X-rays, and UV rays, they're quite high energy. They've got very small wavelengths. But gamma rays are more dangerous, I would say, than UV rays. So we're getting kind of from being more dangerous to being less dangerous. They're all just everywhere. There's always background radiation of this electromagnetic radiation. But then after ultraviolet radiation, we in fact hit what we know best, and that is, of course, visible light. So visible light is just this little teeny tiny part of the electromagnetic spectrum. So it's a type of electromagnetic wave or electromagnetic radiation, and in fact it's just the right frequency and just the right wavelength. So it's about 400 to around about 700 nanometers, so very small waves. But when that type of radiation, that type of electromagnetic wave goes into our eyes, we have receptors and we can see it. So that's how we see everything. We see these light waves or electromagnetic waves bouncing off everything around us and coming into our eyes. So that's really important part of the electromagnetic spectrum. But moving on, the next part of the electromagnetic spectrum where the waves increase again in size, we have here is IR, which stands for infrared. So if you've ever used a TV remote, then you're using infrared electromagnetic radiation. Moving on again is microwave. So the waves are now kind of getting to 10 centimeters-ish in distance, 5-10 centimeters. So that the waves are getting from enormously small gamma rays, can't even I can't get my fingers that close together, to microwaves, which 10 centimeters, and of course they're used in microwave ovens. And then you move on after microwaves. You do move on to the radio waves and long radio waves, and these waves, so electromagnetic radio waves, is how information is communicated to your radios and also your TVs and also mobile phones. So electromagnetic waves. So this is a radio tower transmitting electromagnetic waves to a radio or a television. They're extremely useful, but they're really, really very different. So we use them to transmit communication to televisions, radios, mobile phones. We use them in our microwaves, really useful. We use them in television remote controls, but we also use them in X-ray machines. But they're also, if you're exposed to X-rays for a really, really intensive and intense period of time, it can cause damage to your DNA. So, and of course, the important part of the electromagnetic spectrum is visible light. So a whole range of different really properties of the same thing. These are all electromagnetic waves, and they form part of the electromagnetic spectrum.